So hello, this afternoon we continue to discuss about one of the technologies that described previously, which is the solar-assisted heat pump. And in this research, we are only discuss about the energy performance, but we will also do the cost analysis in the later stage. So basically, I will start from the concept. So solar-assisted heat pump is similar like the traditional heat pump. The only difference is the evaporator side here is the evaporator side is replaced by the thermodynamic panels like the solar collectors, which could extract heat from both the environment and also the solar radiation. So from the literatures, it's indicated the surface temperature of the thermodynamic panels is quite crucial for the COP of the SHP system. And also it indicates the limitations existed for the complexity of the system, whole system, if we want to enhance the system, the performance. And also the cost, the system degradation after long-time operation, and also the frequency of maintenance requirements. So also literatures indicates the fast responsible heat storage exchanging unit is required to integrate into residential buildings to avoid the mismatch. Because the mismatch of the systems is quite, its frequency when we do the design of the building retrofit. So it's important for us to avoid the mismatch between the system and the heating supply demand. And also, according to the energy storage, there's only a few literatures indicate that the energy storage is helpful for improve both the system energy efficiency and also for small scale or standalone renewable energy system energy storage in the short term. Okay, so we'll move to the integrated system in this research. So in this research, we integrate the PV panels, solar-assisted heat pump, and the water storage tank for the space heating and the domestic hot water supply. The PV panels and the water storage tank is in most houses is existed, or we need simply to install these products before we install the solar-assisted heat pump. So this system it works like the which we call the ETS, which is the electric thermal energy storage. So the electricity from the PV panels will drive the compressor of the solar-assisted heat pump to work. And also, the evaporator will extract the heat from the environment and solar radiation. So with both improved the heat pump work, the heat from the condensation will flow to the hot water storage tank, which stores the heat generated by the heat pump. Which means the electricity from the PV panels could be stored as the thermal water form. So this could be used at nighttime or when the solar radiation is not efficient. So this could it can significantly improve the whole system performance while we use the free energy from the PV panels. So according to the modeling we have done for 4 building pilots for the which is from SureFit project from Portugal, Spain, and Greece and UK pilots. According to the simulation results, we find the heating COP as described here with the relation related to the surface temperature of the thermodynamic panels. And also the surface temperature is correlated as the formulation here. We included the global solar radiation following on the panels, and also the wind speed and the ambient air temperature near to the surface panels. And also, although we have did the 4 building pilots, we have find that the COP correlation formula is similar to this one. So we will use this for case study simulations. Here, sorry, this mistake is add ice. So we get the heating and domestic hot water demand from the Auto University, which input into our demand sections. And then I use the Energy Pro software to simulate the performance with codings into the solar assisted heat pump. And this way with PV panels and the grid electricity drives the heat pump work and then go to the storage tank, which supplies the demand when required. This is the space heating demand and hot water heating demand in our project I have listed here. And then we go to the simulation results. It indicates with only the solar assisted heat pump, the COP is around 3.4 to 3.6. It's like stable for this any new COP. But with integrated PV, SHP, and water storage tank system, the COP, you can see there is a significant improve to highest of 9.2. And also we listed here for the required heat pump capacity with only the solar assisted heat pump. But it's reduced to the, here we can see the integrated system, and also the imported electricity from the grid is reduced a lot compared for these two with only the system or the integrated systems. And this is the solar assisted heat pump performance simulated only the solar assisted heat pump. And the first figure is the heating demand and the heating supply for the heat consumption, which is the blue one, and the red one is solar assisted heat pump heat generation. It needs to be matched when only the heat pump is worked. And we can see the electricity consumption, the total demand, and the electricity for the heat pump. But we can see for integrated system, the heating demand, we can see the heat consumption from the building is here with blue lines. It keeps the same as only the solar assisted heat pump. But the heat pump is only work when the PV panels it generates the electricity. So it's fully operated with solar when the PV solar is generated electricity. So we can say the peak load is reduced. Also from here, solar assisted heat pump is almost 2 kilowatts. But we can compare in the previous one, the solar assisted heat pump is like 3 or more than 3 to 4 kilowatts. So it's reduced to almost double of it. And the last one is thermal storage from the water storage tank. We can see that when the solar assisted heat pump is not work, then the heat is from storage tank to supply the heat consumption in the buildings. And all these two figures is extracted from the UK pilots. So this research we did investigate for the PV solar assisted heat pump and the TS integrated system for both space heating and hot water supply. And we investigate for the 4 pilots in the EU project SureFate. And we can see the grid imported electricity have a significant reduction, which is annual data for 27% to 61% in UK, Spain, Portugal, and Greece pilots. And also COP improvement is very high, with highest of 9.2 with integrated systems, compared with the only work of the SHP system. So
Okay,
that's
thank
all.
you.
Thank you.
Any questions? Okay, any questions? Yeah, please go ahead.
Sorry, yeah, can I just ask a quick question? Your results show your new system is quite really good, like the performance is increasing and everything is quite good. But I just got a very quick question. You've been modeled the energy consuming and the heating demand and cooling demand, but did you just validate it? How do you guarantee the accuracy about your simulation?
Okay, so the heating demand and the domestic hot water demand is, according to the integrated work from Waste Auto University, and this model has been validated according to the two parts. The first is the energy bills from the building pilots, and secondly, we also did the monitoring for the energy consumption. So this could be. We are still monitoring it, and after it, we will validate it again according to the latest and new performance.
Thank you.
Yeah, so we do lab tests first, and then after the lab test, we do a field trials and get all the data and compare with modeling. Okay, thank you. Any other questions? Okay, thanks, Kechu.
Okay, thank you.
We move now.